All right, to start out our Unit 6, we're going to begin with Topic 6.1, how to analyze numbers using linear strategies. Sounds like a lot of fun, but it's important to remember that we've actually learned how to analyze numbers using other strategies that we've focused on here at the beginning of the year. I mean, don't forget that we spent a lot of time talking about how to analyze numbers using sinusoidal strategies, a sine wave. And then we just finished a unit on talking about polar math, and so analyzing numbers using r and theta. But now we're going to review the concepts of linear strategies. And remember, linear just means that we have a straight line. And of course, straight lines, one of the most popular things is that they have slope. So let's talk about slope. It's something you've heard about before, but it doesn't hurt to be reminded that slope is always y2 minus y1 all over x2 minus x1. Of course, that talks about subtracting the y values and the x values of a pair of points. We also have horizontal lines. Of course, a horizontal line has zero slope, but a vertical line has undefined slope. Remember that if you have a vertical line, that your denominator would be 0. And of course, that's a mathematical no-no. Let's do a problem that involves slope. We're going to step right up and do a problem that goes a little deeper. We're going to try to find k. So that the slope between these 2 points, 2, -5, and -1k is equal to -4. Good problem, but all we really have to do is just plug into our slope formula, and I hope you would plug -4 in for the slope. I hope that you would trust the subtraction of the x and y values. Of course, it's the y values that you want to subtract first. It turns out that one of the y values is k. The other y value is -5. Now, when you subtract -5, it looks like k minus -5. Of course, that's going to become a plus, but we'll get to that in a second. Now, since you're subtracting the second point, then we want to start with the second point again. So we'll start with -1, and we'll subtract that 2. So we're setting up a little formula, and we're going to, of course, solve this for k. Now, if you do a little simplifying, you get k plus 5 all over -3. And then we can keep solving. I hope that you would take this -3 and multiply it over. So now we're just staring at 12 equaling k plus 5. So it looks like k equals 7. Nice little problem. Makes you think about your slope formula. Moving on, a conversation about linear strategies wouldn't be complete without y equals mx plus b. Now remember, y equals mx plus b is the equation for a line. Of course, a line that has a slope and a y-intercept. So if we're trying to write an equation, then we want to find the slope. And we'd want to plug that in for m. And of course, we want to find the y-intercept, plug that in for b. Sounds pretty easy, right? But you got to remember how to do that when you're given some information. Like here, we're given 2 points, and we want to try to find an equation. We want to try to write an equation that would pass through those 2 points. Now, although it's not necessary, sometimes it can still be helpful to just think about what you're really doing here, and that is that you have a line that passes through the point 6, -2. Here's 6, -2, and the point 4, 1. So again, even though it's not necessary to draw this, it is helpful because you can see that our line has a particular slope. We can see that our line has a particular y-intercept. But what we want to do is we actually want to find these things, of course, using some formulas. So how about our slope formula? You want to carefully subtract the y values. I always like to subtract the second y value minus the first y values. That's going to be 1 minus -2. And then I'll subtract the x values. So again, the second x value is 4 minus the first y value, which is, the first x value, which is 6. All right, so careful with the math, but we get 3 over -2, otherwise known as -3/2. Now, since we're trying to write an equation, I'm going to go ahead and plug -3/2 in here for m, but I'm going to be careful to leave the rest of my equation undone because, of course, x and y will actually be the variables, but b is what I'm trying to solve for. Now, remember how you did this? You take one of these points over here. Which point do you like? Do you like the first one, 6, -2, or do you like the other one, 4, 1? I kind of like 4, 1 because it's all positive. So we're going to plug that in for x and y. Now, of course, you want to plug it in carefully. You plug a 1 in for y, and you plug a 4 in for x. Okay, now if I plug those numbers in, I'm getting myself ready to solve for b. And that's the whole point, because we're solving for that y-intercept. Do some careful simplifying. Looks like you're going to get 1 equaling negative 6 plus b, so that means b would equal 7. Now, the answer is an equation, right? So when we write the equation, we want to go back to y equals mx plus b. Obviously, we still have our slope, but now we have our y-intercept. So we get y equals negative 3 half x plus 7. Take a look. Take a look at the line that we drew a moment ago. Looks like the same line. It has a negative slope. It's got a y-intercept up here at 7. All is well. What else can we do with equations of lines? Well, how about this type of question, trying to write an equation if we are given another line. Now, what we're going to try to do is write an equation that would be perpendicular to 2x minus 4y plus 5, and then it passes through the point 1, 3. All right, sound familiar maybe from geometry? Well, remember, perpendicular is just a fancy word for a certain type of slope. So in order for us to come up with an equation that would be perpendicular to this problem, first thing we're really going to have to do is we're going to have to find the slope. So how do I find the slope of this equation? Well, I think that we're going to have to take 2x minus 4y plus 5. We're going to have to solve that for y. We're going to solve that for y. Now, when you solve that for y, you're going to want to move 5 over here. You're also going to want to move 2x over here. So we'll subtract the 2x and we'll subtract the 5. Now we have ourselves a negative 2x minus 5. You're still solving this for y, so let's divide away this negative 4. And remember why we're doing this. We want the slope. We want the slope. So how's that going? Looks like the slope is 2/4. Or if we want to simplify that, we could say the slope is 1/2. Now, we want the slope because we want a perpendicular slope. The perpendicular slope is not 1/2. Do you remember? It's the opposite reciprocal. Now, the opposite reciprocal of 1/2 would be negative, because it's the opposite, and then 2 over 1. Of course, that's the same as negative 2. All right, now that was a little fancy, but we've got ourselves a slope. And if you have a slope, just like we did in the other problem, you plug it in for m. Of course, after you plug that in for m, you're just on a little hunt for b. And that's where that point comes in. Okay, the point 1, 3 is going to get plugged in very carefully for x and y. Remember, you want to plug 3 in for y. You want to plug 1 in for x. It's not backwards. You just have to be careful. Make sure you're plugging in for x and for y. All right, solve this for b. Add 2 to both sides, right? Add 2, and b equals 5. Now, once you know that b equals 5, then you've got yourself an equation that has that perpendicular slope, okay, and then our y-intercept. Ready for some more linear concepts? Just have a couple more. How about graphing a line? A concept that I know you've been doing since Algebra 1, but never hurts to go over again. There's actually 2 ways to graph a line. Sometimes students prefer one over the other. Sometimes students don't realize that there are 2 ways. Let's talk about that x and y-intercept method. I like x and y-intercepts because they use zeros, and zeros are supposed to be easy. You see, the x-intercept is always going to be when y equals 0. Okay, well, what do I do when y equals 0? I can plug a 0 in for y. What happens when you plug a 0 in for y? You get some cancellation, right? I always like to think about kind of covering up the y term because, well, it's going to equal 0. So I'm basically looking at 2x plus 12 equals 0. 2x plus 12 equals 0. Well, that's going to happen when x equals -6. Okay, we got ourselves an x-intercept. The x-intercept would be -6, comma 0. Whoop. How about the y-intercept? How about the y-intercept? I don't want to say it's the opposite, but anytime you have a y-intercept, it's when x is equal to 0. What are you going to do with x equals 0? You're going to plug it in. You're going to plug it in for x. Of course, what happens when you plug that in for x? You get some cancellation, right? You get 2 times 0. Once again, I always like to think about just kind of covering that up with my hand because, well, it's gone. And now I have -4y plus 12 equals 0. -4y plus 12 equals 0? Well, that means y equals 3. Y equals 3. You just found yourself the y-intercept, 0, 3. Okay, now this is supposed to be pretty slick and pretty quick way to come up with 2 points. You found the y-intercept, you found the x-intercept, you got yourself 2 points, you draw the line. And of course, the line that we drew is actually the line represented by this equation. Okay, don't forget, an equation with x and y is going to be linear. Okay, how about y equals mx plus b? Y equals mx plus b, I know that that you like that method. It's taught often, and we actually went over it on the other slide. All you got to do is take your equation, make it equal 0, make it equal y, right? You want to make it equal y. So you're going to move 2x. Okay, you're going to move 12. Get ourselves to a -4y equaling a -2x minus 12. And of course, solve this for y equals. When you solve it for y equals, now be careful here. This is why we're going over this. You have to take that -4 and you have to apply it to both the parts of the numerator. It's called the Hart method, like we talked about when working with sine and cosine identities. But nice little y equals mx plus b equation. Y equals 1/2 x plus 3. Now, y equals 1/2 x plus 3. What is that? It's a line. What line? It's a line that has a y-intercept of 3, right? Remember, you start with the y-intercept. And has a slope of 1 over 2. If I go up 1 and over 2, I start to find myself getting a line. Line looks familiar. Yeah, it's the same line that we graphed on the other slide. Okay, that's because it's the same equation. Just graphed it with a little different strategy. Okay, x and y intercepts, plug in zeros. Y equals mx plus b. Who doesn't like that now and then? Solve for y. Get yourself a slope and a y-intercept. All right, one more idea as we review some linear concepts. Application problem. Not a bad application problem. Okay, maybe it's not real interesting to you, but it's practical, it's realistic. Let's say we got some copy machine. Must have been a heck of a copy machine, $25,000. That's what it cost in 2006. And it's going to drop $2,000 after 10 years. Okay. Now, if we want to analyze this, like the first questionnaire, to find the average annual depreciation rate, might be helpful if we think about that as a slope. When you hear the word average annual rate, that's like a slope. Okay, but slope is usually easily found with points. Okay, now you might not need to do this for every problem, but I'm doing this to help you guys when you get to a harder problem to think about the numbers that were given, again, as points. And so 25,000 in the year 2006, well, that could be thought of as the point 0, since it's the starting value, 0, 25,000. And then 2,000, or dropping to 2,000 in 10 years, that could be thought of as the point 10, because it's 10 years later, 2,000. You see, it's all right to take data and to interpret it as a point. Typically, the x value will be the time, and the y value, in this case, would be the money, but it would be whatever value we're talking about. Now, look what happens here. If you subtract your y values, you would subtract 25,000 minus 2,000. Pretty easy to do. That, of course, is going to come out to 23,000. And if you subtract your x values, well, again, pretty easy to see that that's going to come out to be 10, but technically negative 10, right? Now, by the way, I don't want to say I'm subtracting this backwards, but I'm just subtracting it in a consistent manner. As long as I'm subtracting both x and y the same way, I'm allowed to do it in any order I want. But what's happening here is we're getting a negative slope because this copier is losing. It's losing, if you do a little simplifying here, $2,300 per year. Okay, now we know it's per year because we divided the denominator. It used to be per 10 years, but now it's per year. And again, makes sense. Makes sense that it's negative. How about the next question here? What do we got? We want to write an equation. Okay, well, we just got done writing some equations. They typically come in the form of y equals mx plus b. This time, why don't we do v equals, since it's value equals mx. Now, we found the slope. And how about we use t instead of x, t for time, and got ourselves a starting value. Starting value, you can just plug it right in there for b. Pretty standard linear equation. It's got a slope, it's got a starting value, and in this case, we can use it to answer a question. You know, if we want to answer a question, what do we got here? We want to find the value of the copier in 2004. Now, to do that, we got to understand that 2004 would represent a certain x value, or in this case, t value. And, oh, it looks like we're going backwards in time. Okay, well, that just means that I'm going to plug in a -2, since it's 2 years before the starting value. It's fine, as long as my x value, or in this case, t value, matches with how I just set up the rest of the problem. So does it make sense? If we're going to kind of go backwards in time, my value should actually go up. Actually, it looks like it goes up by 4,600. So we're now going to be worth 29,600. Again, pretty expensive copy machine. Must be printing money, or maybe gold. Linear equations. All right, now it's your turn. You're going to get to practice a couple problems as you review in our Unit 6.